"Beam me up" is one of the most famous catchphrases from the Star Trek series. It is the command issued when a character wishes to teleport from a remote location back to the Starship Enterprise. Now, according to new research from the University of Rochester and Purdue University, teleportation may also be possible between electrons. In a paper published in Nature Communications and one to appear in Physical Review X, the researchers, including John Nichol, an assistant professor of physics at Rochester, and Andrew Jordan, a professor of physics at Rochester, explore new ways of creating quantum mechanical interactions between. The research is an important step in improving quantum computing, which, in turn, has the potential to revolutionize technology, medicine, and science by providing faster and more efficient processes and sensors. Spooky action at a distance. Quantum teleportation is a demonstration of what Albert Einstein famously called spooky action at a distance, also known as quantum entanglement. In entanglement, one of the basic of concepts of quantum physics, the properties of one particle affect the properties of another, even when the particles are separated by a large distance. Advertisement. Quantum teleportation is an important means for transmitting information in quantum computing. While a typical computer consists of billions of transistors, called bits, quantum computers encode information in quantum bits, or qubits. A bit has a single binary value, which can be either 0 or 1, but qubits can be both 0 and 1 at the same time. The ability for individual qubits to simultaneously occupy multiple states underlies the great potential power of quantum computers. Scientists have recently demonstrated quantum teleportation by using electromagnetic photons to create remotely entangled pairs of qubits. Individual electrons are promising qubits because they interact very easily with each other, and individual electron qubits in semiconductors are also scalable, Nichol says. An individual electron is like a bar magnet with a north pole and a south pole that can point either up or down. The direction of the pole, whether the north pole is pointing up or down, for instance, is known as the electron's magnetic moment or quantum spin state. If certain kinds of particles have the same magnetic moment, they cannot be in the same place at the same time. That is, two electrons in the same quantum state cannot sit on top of each other. If they did, their states would swap back and forth in time. The researchers used the technique to distribute entangled pairs of electrons and teleport their spin states. We provide evidence for entanglement swapping, in which we create entanglement between two electrons even though the particles never interact, and quantum gate teleportation, a potentially useful technique for quantum computing using teleportation, Nichol says. Our work shows that this can be done even without photons. The results pave the way for future research on quantum teleportation involving spin states of all matter, not just photons, and provide more evidence for the surprisingly useful capabilities of individual electrons in qubit semiconductor. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new technology updates. Bye bye.